Welcome to the next scale model. We're dealing with 1 to a millionth now, and we'll call that micro. Micro comes from Greek, meaning very small. And in our last scale model, we were looking at grains of sand, at red blood cells, and these things are now enlarged by further 1,000 times. So from the actual scale, we're enlarging something by 1,000,000. And so let me show you what the red blood cell looks like now. This is, we've gone now to 7 meters across. 7 meters across kind of reminds me of the movie Fantastic Voyage from 1966. So in that movie, they miniaturized the submarine and its passengers down to a microscopic level, and then they injected it into a patient. As they're looking out the window of the submarine, these red blood cells are huge and the submarine is bumping up against them. And so I venture to say that they probably used the scale factor of about 1,000,000. Let's look at a grain of sand. And if we look at beach sand, we've looked at this in the previous scale model for sure, right? And if you multiply that by 1,000, you get a boulder about a meter across. Now, in this scale model, if we multiply that by 1,000,000, right, it's something really huge. So the average grain of sand is 0.5 millimeter. Multiplied by 1,000,000 is 0.5 kilometer, right? I mean, it seems counterintuitive, but this grain of sand, 1 grain of sand is the size, would be as tall as a skyscraper, and it would look like a small mountain. And I just happen to be near a mountain that's about 420 meters tall. There it is in the background. And this is going to be our grain of sand at this scale model. And we're going to go up and see what the view looks like from on top. All right, so here we are at the top of our grain of sand that's been enlarged by 1,000,000 times. You might be wondering, well, 1,000,000 grains of sand only amounts to a little bit. How come these ratios seem so different? Well, in a scale model, we're enlarging or we're reducing by the length, not by volume. So even though this is about 1,000,000 grains of sand, if I were to line them up by length, they would reach about 500 meters. But we're not really focused on volume too much. All of our scale models, it all scales mostly by length. Where are the atoms? Are they still too small to see or not? And the diameter of an atom, so that goes all the way out to the electron shells, they're between 0.1 and 0.5 nanometers. And if we enlarge that by 1,000,000 times, that's 0.1 to 0.5 millimeters. And guess what? That's the size, again, of sand. So in this scale model, atoms look this big. So there's a curious relationship between atoms and grains of sand. So an atom to a grain of sand is the same ratio as a grain of sand is to this small mountain. The next time you're at the beach and you pick up a grain of sand, you can think of it, 1 grain, as a little mountain. And that mountain is made of sand. And that sand represents the atoms of the universe. So for a long time, we thought the atom was the fundamental object of the universe. But it turned out the atom is made of much smaller things. And in order to explore that, we need to go another level down, and we need to visit the scale model of 1 to 1 billionth. So we'll see you there.